All right, let's try to find the zeros of a polynomial of degree 4. So in this example, there's a polynomial h of x. And notice it's already in descending order. So you see the 4, 3, 2, 1, and 0. So we want to have that in descending order. What we're going to do is then use the rational roots theorem. And rational roots theorem says if there are rational zeros for h of x, then possible rational zeros could be the plus or minus factors of -3 all over the plus or minus factors of 7. So what does that mean? What does this diagram here really translate into? It translates that if there are possible rational zeros, they would be -3, -1, -3 sevenths, -1 seventh, 1 seventh, 3 sevenths, 1, and 3. Now, not all of these can be the zeros because there's only degree 4, so only at most 4 of these, including multiplicity, okay? So now we're going to proceed to use synthetic division. But if one of these is truly a zero, what does that really mean? It means we're going to solve an equation. So I'm going to write that equation now. It really means if we're looking for zeros, we're really solving this equation right here. Okay. Now, I'm going to draw another aside portion. So notice I'm actually trying to organize my work so I don't conflict with equations on the far left side. So on the aside, what am I going to do? We're going to set up synthetic division. So I'm going to set up a 7, -29, 24. That's not a very good 24. Let's try that again. There's a 24, there's a 1, and then there's a 3. So let's pick on a possible 0. So let's try 1. You know, there's so many choices down there, but let's go ahead and try 1. So what I'm going to do is put a 1 right here. And remember synthetic division, we bring down the first coefficient, then we're going to multiply and add. So we're going to do 7 times 1 and then add it to -29, which gets you -22. We're going to do the same thing, -22 times 1, we're going to add it to 24, we'll get you 2. And then we go 2 times 1, which is 2, add it to 1, we get, we get 3. Oh, I just realized I made a mistake. There's a negative symbol right there. So let's try that again. 3 times 1, and we're going to add it to -3. We get a 0, and that is actually the remainder of 0. So that's good. That also tells you that 1 is a 0 of this polynomial h of x. So if 1 is a 0 of the polynomial, then by the factor theorem, we know that the polynomial has a factor of x minus 1. Let's go ahead and write that. The synthetic division says the remaining factor is 7x cubed minus 22x squared plus 2x plus 3, parentheses. That's pretty cool. We get another polynomial descending order. Once again, we got a little fortunate here. We got a 7 and a 3. So what does that mean? Well, we could actually do synthetic division again. let's portion this a little bit. Draw a line here. So let's set up synthetic division again. Now we have what? Now we have 7, negative 22, 2, and a 3. Now, possible rational roots. Let's see if 1 is, I'm sorry, not rational root, but rational 0. Let's see if 1, let's see if 1 is actually a 0. Bring down, multiply and add. Negative 15 times 1, negative 15, negative 13. Negative 13 times 1 is negative 13. Now you get negative 10. Notice we do not get a remainder of 0 here. So that means 1 is not a 0. It's not a 0 of the polynomial. That's what we mean. So let's try something else. Let's bring down to 7. Well, how do I try something else? I'm going to draw it right here. I'm going to make an educated guess of what the rational 0 is. Let's guess 3. And it really is guess, and then of course we're going to do synthetic division. We'll bring down to 7. We're going to multiply and add. 7 times 3 is 21. Add it to negative 22. It's negative 1. Negative 1 times 3 is negative 3. Added to 2, it's negative 1. Negative 1 times 3 is negative 3. Added to 3, which is now 0. Whoa. Okay, that is good. That means 3 is a 0 for this third degree polynomial. Once again, by the factor theorem, we now get this. Oops. Let's try that again. I meant to write x minus 3. And now we have what? 7x squared minus x minus 1. And now we're down to a familiar quadratic. So usually with a quadratic expression, we try to break it up into factors. Notice that 7 and 1, those are prime numbers. There are not many choices here. It turns out you cannot factor this in your head. So if you can't factor this in your head, try using the quadratic formula. What does that mean? That really implies that we're solving this equation now. 7x squared minus x minus 1 is equal to 0. And the quadratic formula says x is the opposite of b plus or minus the square root of b squared minus 4ac all over what? All over 2 times a. And if we keep writing, let's try to substitute that x. What is, well, here, I'll write it this way. Let's just be consistent and write equations. We get 1 plus or minus the quantity negative 1 squared minus 4 times 7 times negative 1 all over 2 times 7. And we get x is now equal to 1 plus or minus 1 plus 28, which is 29. If you don't mind, I'm just going to write a 29 right here. That is a 29. 29 is a prime number. Oops. All over what here? 14. And there we go. We actually have all our zeros. Let's write a final answer. So the zeros of h of x are 1, 3, and we got two more. 1 plus square root of 29 over 14. And we got what? 1 minus the square root of 29 over 14. And there you go. Now, what's so cool about the artwork on this whiteboard? Well, if you look very carefully on the left, everything is very consistent. This is an equation. This is an equation. This is an equation. This is an equation. So a lot of times when we're solving equations, you're writing answers that are conveying a pattern. So this is just a pattern of equations. That's kind of nice. All right, I hope that is helpful.